region that's bounded, that means on either side, is 2 radii. So it's a radius and a radius on either side. And then like your third side of your sector is its intercepted arc. So what that's saying is if we're looking at sector APB, or like you can think of it as like a slice APB, you have your 2 radii that it's bounded by, and then the intercepted arc of its central angle. And then we have this sentence here is just describing this formula here where we can set up to find the area of a sector. It describes it in terms of ratios of the area of your sector divided by the area of your whole circle is equal to the measure of your intercepted arc divided by the measure of all of your whole circle together, 360 degrees. So you may see this written sometimes, or I'll write it in the key as, so like we could just say this is whatever sector we're talking about, divided by pi r squared is equal to the measure of AB divided by 360 degrees. So you can see how we can go from here to here. The only difference is if we multiply by what's on the denominator, so pi r squared on both sides, we'd be left with just the area of our sector is equal to the measurement of our intercepted arc divided by 360. So that's the ratio of your arc to your whole circle times the area of your circle. So when we go this, we're really just going to do a bunch of like plugging in, following what we have up here. All right, so we're going to find the area of the sectors formed by angle UTV. So we have to find 2 areas of, when you have an angle, it makes 2 kind of slices. Like here we have the red slice. We're going to find the area of that. We also can go and find the area of this blue slice. We're going to do both of those. We'll do the red one first, then the blue one. All right. So the area of our sector, and I'm going to follow just this piece here, but know that this comes from just this, you can go over, but this one's easier, then we don't have to cross multiply. If we're solving for area of a sector, we just have to plug in things on our right-hand side. So let's use we'll use A for the area of our red sector. So that's the measure, it's equal to the measure of our intercepted arc. And whenever we have a central angle, our central angle measurement is the same as our intercepted arc measurement. So that's 70. That means our intercepted arc also has a measure of 70 degrees. So we can start saying this is our area is equal to 70 degrees divided by 360 degrees times pi r squared. So that's pi times your radius squared, and our radius was 8. So you could say 8 squared. How I like to do this is simplifying my pi r squared piece first before I mess with anything over here. So we could say this is equal to 70 degrees divided by 360 degrees times 64. Oop, I just wrote a 64 pi. And when we're at this point then, it's just where you can think of it as you're multiplying 2 fractions together. That's really, you could write as 64 over 1. So you multiply what's on the top together, and we multiply the bottom. So again, you take 70 times 64, and you keep the pi on there. So that would be 4,480 pi. Divided by 360 degrees. And then you could type this onto your calculator as is without any parentheses needed. because your calculator would do this multiplication first and then divide by 360. So we'll get an approximated answer. We're going to just round to the nearest hundredth. So that'll be 39.10. And that'll be in, since we're talking about area, that's inches squared, will be your units. So that's the area of our red sector, our red slice of our circle. We'll now do the blue slice. This is following all the same steps, but the one thing that's going to change is the measure of our intercepted arc. Looking over at our diagram, we know that altogether the degrees of a circle have to add to 360. So we already used 70 of it for a red arc. To find the measure of our blue intercepted arc, we'd have to take 360 degrees minus 70 degrees. So I'll give you 290 degrees. So that's what we're going to plug in for our arc measurement when we do this. So I'll do this in blue now since we're doing our blue arc. Your area, or your A, is equal to, this time it's 290 degrees divided by 360 degrees times our area of our circle is still the same. So it's still 64 pi. I keep forgetting to write the 4. 64 pi. And we'll do the same thing. Multiply your top and your bottom. So if we multiply 290 times 64 pi, you get 18,560 pi divided by 360 degrees. Again, we'll just round that to the nearest hundredth. So we get 161.97, and then keeping our units on there, inches squared. We'll talk about area. Another way, if you don't want to do this twice, another way you could find the area of your blue measurements is, it's actually kind of quicker too. If you know the whole measurement of this circle, the area would be 64 pi. You could just subtract off the area of your red segment, so 39.10, and you would get out the same thing, 161.97 inches squared. So a lot more efficient way to do it, but it's good to have like the conceptual understanding of the formula way. Your homework is kind of, it focuses on doing these type of calculations. Again, big ideas is picky with rounding. I know on number 11, it's 11.00, so just when you get to that, it's 0.00. That was giving some people some issues. First hour, they just want to put in 11, but the big idea is on the decimals. All right, next piece. We're finding the area of a circle now, given we know just the area of a slice of it. Think about, okay, if we know that a 40-degree slice is 35 meters squared, how many times can we evenly slice this 360-degree circle into 40-degree slices? That's in like numbers saying, okay, well, what's 360 degrees divided by 40 degrees. Well, if you do that, you get out 9, which means in this circle we can make 9 equal sectors. And each sector would have an area of 35 meters squared. So if we take each of those 9 sectors that make up our whole circle altogether, we multiply them by the area of each one, 35 meters squared, we will get the area of our whole circle. So 9 times 35 is 315. So the area of our whole circle is 315 meters squared. For like a visual, I don't know if I could do this, but you could think of this as you're splitting it just into 9 slices. 1, 2, 3, 4, 5. I can't evenly divide a circle by 9 right now, but that's how you find the area of a circle, given, the area of just one slice. All right. Last example, kind of what we've been doing a lot. We've done a lot of problems like this. Finding the area of kind of an odd shape. We're trying to paint the outside of this archway. So we're trying to find the area of what's shaded in blue, so we can buy enough paint. We don't want to buy too much paint. We just want the right amount. So think of this as, to find the area of the blue, it's like taking the area of this whole square subtracted by the area of our archway. So we have to find each of those pieces. So the area of just our big wall altogether, so just this whole piece, area is your length times your width. So the length of our wall is 26 because we had this 16-point segment and 10. And our width is 36. So we would say this is 26 times 36. You would do that on your calculator. 26 times 36 is 936. And we'll keep our units on it. So this will be feet squared. We're in feet, yeah, we're in feet. So now we have to take away from 936 the area of our archway. So whatever is our area of our red space. So our red space is really made up of 2 smaller shapes. It's made up of a rectangle and a semicircle. So I would do each one on its own. First, find the area of this rectangle. So I like to do area, then like a little subscript of saying a rectangle, so I know what I'm finding of it, because we have a lot of pieces to this. So again, to find the area of a rectangle, we take the length times the width. So the length of this would be, we go from here to here, so that's 16. We go from side to side is 16 as well. So both our length and our width are 16. So do 16 times 16. And that'll give us 256 square feet. Right. So we find this is kind of just that piece, area of our rectangle. Now we're going to find the area of that semicircle. So I'm going to write area of semi. Semi just stands for our semicircle. To find the area of a semicircle, well, just to find the area of a whole circle, that's pi times r squared. But we don't want the full circle, we only want half of it. So if you just stick a 1/2 in front of it, you're splitting your area up into 2 equal halves. And so then we'll just find the area of this top portion. So this will be 1/2 times pi times our radius of our circle. If this is like the center of your semicircle and your diameter is 16 feet, that means your radius would have to be 8 feet. So then this would be 8 squared. So again, we have 64 pi. We divide 64 by 2. So we get 32. So the area of our semicircle is 32 pi feet squared. And now we have all the information we need to find our area of what we're going to paint. If we take the area of the wall altogether, which was 936, and it's nice because we labeled it, And then we take away the rectangle part. So we take away the 256. Then also we take away a semicircle area, which is 32 pi. We're going to be left with just the outside of our arc. So first, I would subtract kind of your whole numbers. 936 minus 256 is 680. So 680 minus 32 pi. And then you could put that in your calculator, get out an approximate answer, round to the nearest hundredth. 579.47 feet squared. So that's the area of just what's in blue. The area of that you have to paint. So you're not going to paint a doorway. Rounded to the nearest hundredth.